Hello and welcome back to another episode of Math with Sohn. Today we are going to be talking about trigonometric ratios, which most people would just call trig ratios. Specifically, we're going to be talking about sine, cosine, and tangent, which are almost always abbreviated as the sin, which we call sine, cos, and tan. Okay? There are three formulas that you will need to be using, and they will be provided on most formula sheets for any big standardized test. So sine of the angle is equal to the opposite over the hypotenuse. Cosine of the angle is equal to the adjacent over the hypotenuse. And tangent of the angle is equal to the opposite over the adjacent. Okay? Now, normally you wouldn't write out the whole words. I didn't even write out the whole word for hypotenuse. And as of right now, that means very little to you. Okay? So what is important to realize is these are going to be used with a right triangle, and you could be asked to do one of three things with this. You could be asked to find a missing side out, or you could be asked to find a missing angle out, and you could use these three things to do that. The other thing you could be used to do is just state what we call the trig ratio. So if this was angle A right here, I could go across from angle A, and this would be considered my opposite side. This would be considered the hypotenuse because it's across from the right angle, which means this side right here would be the adjacent. That is in relationship to angle A. All right? So today we're just going to be listing out the trig ratio. So given some information about a right triangle, we're just going to be filling in the opposite and the hypotenuse. We're not going to be solving for any sides. We're not going to be solving for any angles using the trig identities. That's for later. All right. So let's say that this opposite side was 4 and this hypotenuse was 5. If I wanted to write out what sine of angle A would be, if I had a question like sine of angle A equals, well, then it would just be the opposite over the hypotenuse, which in this case would be 4 for the opposite over 5 for the hypotenuse. Now, sometimes you will be given all three sides of the triangle. Sometimes you're going to be only given 2. But it's a right triangle. If you want to find that third missing side, you just have to use the Pythagorean theorem. So if I wanted to find this adjacent side, which I'm going to, because I'm actually going to write out what is cos of angle A as well, and what is tangent of angle A as well, I just have to use the Pythagorean theorem to do it. So the Pythagorean theorem would be a squared, which I'm going to call the 4 squared, b squared we don't know, c squared is always the hypotenuse. We get 16 plus b squared equals 25. And when I subtract 16, I get b squared equals 9, which means b, or the adjacent, is 3. And that's the only real math you have to do. Once you figure out what the adjacent side is, then we can fill in our cosine and our tangent, because cosine is the adjacent side over the hypotenuse side. So adjacent, we just found out, was 3. Over the hypotenuse is 5. Tangent is opposite over adjacent, so I just have to find my angle A, go to my opposite, 4, and put it over my adjacent, 3. That's it. So that's labeling the trigonometric ratios. Okay? You don't have to do anything else. We are going to go through one more example, but in this next example, we are going to be using both angle A and I'm going to give an angle B as well. Okay? So, if I had a right triangle, as such, and I labeled this A, and I labeled that B, and I'm going to put my sides down as 5 and 12 and 13. So I'm giving you all three sides. We won't have to do the Pythagorean theorem. We are, however, going to figure out what is sine of A and sine of B, meaning sine of angle A and sine of angle B, and cosine of angle A and cosine of angle B, and tan of angle A and tan of angle B. All right, so I'm going to rewrite the sine of an angle part equals opposite over hypotenuse. I'm going to rewrite the cosine of the angle part is equal to adjacent over hypotenuse. And I'm going to rewrite the tan of the angle equals, out of room, opposite over adjacent. All right, so that's something that we could just use to reference. So angle A is here. We're going to do all of the A's first. So I'm going to figure out A, and I'm going to go across from angle A just like before to label my opposite. And I'm going to go across from the right angle to label my hypotenuse. And 5 would be the adjacent. So we're just going to fill in sine, cosine, and tangent based off of the little formulas we have here. Sine is opposite over hypotenuse, so that is 12 over 13. Cosine is adjacent over hypotenuse, so that is 5 over 13. And tangent is going to be opposite over adjacent, so that is going to be 12 over 5. Now, sometimes, pretty rare, but sometimes you can actually divide 12 by 5 and get like 2. But 12 doesn't divide by 5. Imagine if that was 6, we would write just 2. So we've found all sine of angle A's and cosine of angle A's and tan of angle A's. Now I want to focus on angle B. Well, if I change from angle A to angle B, then if I go across from angle B, this is going to be my opposite. Because I'm changing my angle of focus, my 5 now becomes my opposite. My hypotenuse remains the same. But my adjacent, the side next to, adjacent means next to angle B, would be the 12. So when you switch angles, the opposite and adjacent will also switch. With this, we do the same thing. We're going to fill in everything the same way we did before, but our opposite and adjacent had to switch because we switched what angle, which means the opposite side switched. So sine is opposite over hypotenuse. That is now going to be 5 over 13. Cosine is adjacent over hypotenuse, so it's now going to be 12 over 13. And tangent is going to be opposite over adjacent, which is going to now be opposite 5 over 12, opposite over adjacent, 5 over 12. Now there's a few things that you can notice about this. First off, when you switch the angle, tan just flip-flops. Turns from 12 over 5 to 5 over 12. More importantly, and a specifically geometry standard, which is tested a lot, is that sine of one angle, angle A, will equal cosine of the other angle. So sine of angle A was 12 over 13, which means cosine of the other angle, which is B in this case, is 12 over 13 as well. And it worked for angle B as well. Sine of angle B was 5 over 13, which means cosine of the other angle, angle A, is 5 over 13. That is something that we need to commit to memory. Sine of one angle will be equal to cosine of the other angle, whether we label it with A's and B's or whatever other letter we choose. So sine of this angle would equal cosine of the other angle, which in this case was B. And it works the other way around. Cosine of one angle will equal sine of the other angle. So it's a reverse effect, and that's something you need to commit to memory. All right? For the next few episodes, we're going to figure out how to use these sine, cosine, and tangents, not just to write them out, not just to write the ratios, but how to use them to figure out missing sides without the Pythagorean theorem and missing angles if you don't know the angles at all. Okay? So, till next time, stay positive, and I will see everybody later. Bye.